let us discuss some important problems associated with the gravitation concepts. Take down. We already know, according to Newton's law of gravitation, that is universal law of gravitation. What is the universal law of gravitation? What is the formula?
F equal to gm1 m2 by d squared.
So either you can say m1 m2 or capital M and small m. You can distinguish by that. You can either put G capital M small m, otherwise you can put F is equal to G m1 m2 divided by d squared or r squared. So this r is nothing but d. Okay. So various authors use various types of terms. You need not worry about it, but you should be strong in the concept. Okay. Right. Now, let us consider this problem. Take down. What happens? One of you can go to the board and try to solve the problem. I will be guiding you. Anyone, go. What happens to the force? Write down on the board. What happens to the force between two objects? What happens to the force between two objects if one, the mass of one object is doubled. Second question, subdivision. The distance between the objects is doubled and tripled. There are two questions here. Third question, the masses of both objects, the masses of both objects are doubled. Both of them are doubled. Okay. Now, let us symbolically represent all these questions so that it will be comfortable for you. What happens to the force? So they ask about the force. It means that they are using two forces, two types of forces, F1 and F2, and here we are talking about F2. So F2 is equal to what? So F1 is given. Then there are three different questions. In the first subdivision, mass of one object is doubled. Doubled means you have got two masses, M1 and M2, where M2 is doubled. Doubled means what? M2 is twice the M1. Do you understand this? Then the distance between the object is doubled. So the second distance D2, D1, D2 are the two different distances for two different forces, and in the case of D2 it is twice the D1 and also thrice the D1. Are you able to follow? So there are further two questions asked here, doubled and tripled. Do you understand? Then the masses of both objects are doubled. So it means M1 becomes twice the M1, M2 becomes twice the M2. Both masses are doubled. So this is the situation. We need to arrive at the different answers for these different questions. Okay? So first let us proceed like this. Let me consider that is, we have got two types of forces, is it not? Let me say they have talked about let me say FA and FB. That will be convenient instead of saying F2. Okay, FA, FB. In all these cases they asked this is FB and this is FA given. So FB is asked in all cases. Okay, so FA is equal to G into M1 M2 divided by D square. This is one type of force. Okay, this is one set of force. Another set of force, FB, in this case G into, instead of these two different forces between two different masses, so let me say M1 dash M2 dash divided by, and this is totally a different D dash, let me put, so square. Now let us have FB divided by FA. Once we are able to arrive at this equation, we can simply substitute and get the answer. So this is equation 1, this is equation 2. So FB by FA means a G cancelled, and now you have M1 M2 dash M2 dash divided by D dash square into, it's reciprocated, D squared divided by M1 M2. So this is the overall equation. Okay, now we can comfortably substitute here. How? FB is equal to, let us rearrange because FB is asked. FB is equal to M1 M2 dash divided by D1 D dash squared into D squared divided by M1 M2 into FA. Okay, so this is the final equation where we had to substitute. Let us consider the first case. What is the first case? Mass of one object is doubled. Okay, mass of one object is doubled. It means we have FB is equal to one set of, because what happens to the force between two objects if, okay, so one object is doubled means object or distance, mass is, okay, so the first question is mass is doubled here. Now you can put in fact a distance between two distances tripled, doubled, I would suggest rather you can go like this, FB and M1, M2 is equal to what? Twice the M1. Okay, what is that? M2 is twice the M1. So can you substitute? So I have given some clues, based on that you can proceed. Try. Instead of M2 you can put 2M1. No, instead of M2 you can put 2M1. M1, M2. In the first case, one of the masses, what they have given here, what happens to the force between, okay, mass of one object is doubled here. You can maintain the same. M1 is M1 dash only. M1 dash is equal to M1 is equal to M1 dash only. So M2 dash becomes a 2M1. Do you understand? Are you able to follow? Yeah. See, you have got, now listen here. This is a tricky question. See, you have initially one mass, another mass. Previously it was M1 and this is M2. Are you able to follow? And the force of interaction between this D, got it, is equal to what? That is F is equal to G into M1 M2 divided by D square. This is the original formula. And let me consider this is force A. You got this point? Now I have the same type. In this case, let me distinguish this by M1 dash M2. M1 remains same. M1 dash is equal to M1 only. I have not changed. Correct? But instead of M2 I have taken, that is M2 dash, here it is 2M1. Are you able to follow? So 2M1. So this is D. Now FB is equal to G into M1 dash M2 dash. M1 dash is equal to M1 only. M2 dash, that is equal to 2M1. Okay, so you can put 2M1 here. Do you understand this? Divided by, the distance is not changed here. Okay, so it means FB by FA is equal to GG cancel. You can substitute this equation straight away. So how to do this? Let me have this equation because we already derived it. So FB is equal by, what is this? D square. Let me say D, in both the cases distance is same. Okay, so we can keep it as D only. So into the same D square divided by, what about this? M1 M2 originally. Okay, M1 M2. So in that case, now the M1 originally it was it is a doubled almost. Okay, so in that case the M1, there is no change in that. Are you able to follow? There is no change in that. And M1 is also here, they are not discussed about the M2 here. They are changed only M2 dash only. So in that case the original D squared can also be cancelled. So 2M1 divided by M2. Okay, assuming that if M2 is equal to M1, okay, it is twice, is it not? So in that case 2M1 divided by M1, that is also cancelled. So it means FA is doubled. So FB is twice the FA. So you can prove like this. Okay, are you able to follow? So what happens, what is the question asked here? Mass of one object is doubled. Okay, mass of one object is doubled. So in that case, you can say twice the FA, the original force. Now let us go to the second one. The distance between the object is doubled and tripled, and they are not discussed about the M1, M2. Are you able to follow? So let us retain the same. Okay. So let me say, what is that? D1, D2. Second, you can erase it. Right. In the second question, D1, D2. D1, D2 we have to consider, where in the first case D2 is doubled, that is twice the D1. In the second case D2 is tripled, so 3 D1. Let us say the first case. Okay, let us say the first case. So here D2, listen to me carefully. What is our original equation? FB is equal to FA into M1 M2 dash divided by D dash squared into D squared divided by M1 M2. Okay, now FA into, now the mass is remaining constant, there is no change in the mass. So it means what? M1 dash is equal to M1, M2 dash is equal to M2 only, there is no change in that. So M1 M2 divided by, what about this D1? D dash, that is D2, is it not? D dash, here also D dash. So D dash is equal to twice the D1, is it not? So twice the D. Okay, you can simply put twice the D. Instead of D1 you can put D. So it means 2D the whole square, are you able to follow, into D square divided by M1 M2. Okay, now you can strike out both. Now FA into D square divided by 4D square. So you can cancel. It means FB is equal to 1/4 of FA. Okay, got it? Now what is asked? In the second question there is one more subdivision, 3D. So you can simply substitute here. Instead of confusing all these things, you can take only D. So in that case what you can do? The force FA is proportional to 1 by D squared. Correct? And then the next force, because M1, M2, these are all constant. FB is proportional to 1 by D prime squared. Okay. Now FB is equal to FB by FA. So FA can be brought here. So FA into, what is that? This 1 by D1 squared. So D2 squared is reciprocated. So D squared divided by D prime squared. Right? So that is equal to FA into D squared divided by, what is D prime squared? 3D. So 3D squared. 3D whole squared. It means FB is equal to FA into D squared cancel. So 1 by 3 squared 9. So it means FB is 1/9 of FA. Okay. Okay. Now I want to clarify further. So whenever such type of problems are asked, okay, you just check whether distance or the mass are varied. So you can consider that alone. So in that case, how you can write down the universal gas law, the universal gravitation law. Write down F is equal to, F is proportional to M1 M2 divided by, what is that, D squared. Now you can split this into 2. F is proportional to M1 M2. Okay, you can maintain this alone. Similarly, in this case, inverse proportionality only, other being constant, is it not? Okay, now what you can say, that is F1 is proportional to M1 A, M2 A. If you have got any confusion in putting prime, you can put A also. So this is FA. And what about FB is proportional to M1B, M2B. Okay. So simply you can take this, therefore FB by FA, dividing the proportionality will get equal, therefore M1B into M2B divided by M1A, M2A. Is it clear? Okay. So you can maintain this equation. Based on that you can easily fill up and proceed. What about this? Here FA is proportional to 1 by dA squared. FB is proportional to 1 by dB squared. Now by dividing this, FB by FA, proportionality is removed, so you can take this as 1 by dB squared, is it not? So dA squared will be in the numerator, so dA squared divided by dB squared. Okay, so this can be rewritten as FB is equal to FA into dA by dB the whole square. Okay, so you can conveniently change this and effectively substitute here. Are you able to follow this? Okay. Now let me consider the same second problem. In the first case, what they did, what they asked, the dB is twice the dA, correct? In the second question, dB is thrice the dA. You can simply substitute and get the answer. So FB is equal to, in the first case, FA into, what is dA? dA is dA only. What about dB? dB is twice dA. So likewise, you can easily do this whole square. So dA cancel, 1 by 2. Therefore, FB is equal to 1/4 of FA. Got this answer? Is it clear? And similarly, in this case, what you can do? FB is equal to FA into, what is dA? dA is dA only, no change. But the dB is how much? 3 dA. So you can put 3 dA whole square. Now you can cancel dA. 1 by 3 squared means 9. Therefore FB is equal to, so this is a very easy way. Instead of including the masses, you can ignore the masses, because masses are constant here. They are not changing the masses. Do you understand this point? Any doubt? Now in the previous sum, I would have handled in a different way. Okay, but in this case, why I have taken M1, M2 and M1 dash, M2 dash, otherwise say M1A, M2A like that? Because in the third question, it is asked, please go through that. The masses of both objects are doubled. So in that case, we have to suitably write. Okay, take down. The masses of both objects are taken here. So it means, what is our formula? You can make use of this formula, is it not? This one. First write down the formula. FB by FA is equal to, what is that? M1B, then M2B divided by M1A and M2B. Is it clear?
Yes, sir.
A. Now that is equal to, what is M1B? That is doubled. M1B is doubled as the previous case. That is 2M1A. Is it clear? And what about M2B? That is also doubled. 2M2B. M1B. Now let us substitute 2M1A into 2, what is that? M2A. Okay, M2A, it should be M2A. Okay, so M1A, M2A. So you can cancel this, so you can get 4. Therefore, FB is equal to 4 times of, what is that? FA. It means FB will be 4 times of the FA. Are you able to follow this? Okay. So what is the first answer? When F is directly proportioned, when mass of one object is doubled, what happens? It is also doubled. Gravitation force is doubled. That is the first answer. You can write down. In terms of, let us write down the summary of the answer. What is the first answer? FB becomes twice the FA, correct? What is the second answer? What is the second answer? That is inversely proportional to A, so it becomes what? 1/4 of the, yes. So in which we have two cases. Case 1 means FB is, when it is doubled, the distance is doubled means we are able to get 1/4. It means FA by 4, correct?
Yes, sir.
In the second case, FB is equal to
1/9 of
FA by 1/9, that is FA by 9. In the third case, what is that? FB is equal to 4 times the original value, FA. So likewise you can prove. Okay. So do you understand this concept? Take down. Next one important question there. Amit, right. Take down. Next question. Amit buys a few grams of gold at the poles. At the poles. He hands over the same when he meets him at the equator. Now the question is, will the friend agree? Will the friend agree with the weight of gold bought? If not, why? Okay, right. Now the concept is, take down. Actually the earth is not a round shaped, it is pear shaped. at the top and bottom it is almost flat. So you got the North Pole and South Pole. Okay, and this is the equator. So the weight at the pole means that is you got the weight at the pole. It is said that is a few grams at the poles. Let me say he has bought at North Pole. So the weight at North Pole is W1. And he is selling at the equator. Let me say this is W2. Take down W1 is weight of gold. At the pole, North Pole or pole, any pole. And the W2 is the weight of gold at equator. Okay. Now the very important hint here is the value of, take down, this is very important. The value of G is greater at poles. Okay. The value of G is greater at poles than at equator. Are you able to follow? So we know very well at North Pole or at pole. What is W1? mg1. And what is at equator? W2 is mg2. And it is clearly given G1 is greater than G2. Okay. Got this point? If G1 is greater than G2, definitely in this, because mass is same here, so W1 is proportional to G1 here. Mass is not going to change, but we are talking about weight only. W2 is proportional to G2. Okay. Now G1 is greater than G2. It means in G2 it decreases, is it not? G2 is less than G1. You can reverse this. Okay. Therefore W2 is less than W1. Okay. Now the weight will vary, so he will not agree. Are you able to follow? So Amit will not agree. So this is the reason. Got this point? So the value of G is greater at poles than at the equator. So that is the reason. You can mention that. The value of G is greater. Then you may ask me, sir, then why we keep 9.8 as constant? We take as mean value. Okay. So the value of G is greater at poles than at the equator. So the gold at the equator definitely weighs less than than at the poles. Are you able to follow? So naturally Amir's friend will not agree with that. Okay, because there is a weight variation, right? So I hope that is this concept is very, very important, and you have to go through this in detail. Okay, so I will try to ask you some more questions. Take down. You can be seated. Now I will ask some questions. Try to answer. Take down. You can write down all these simple questions. Gravitation is dash unless large masses are involved. Anyone? No. Gravitation is dash unless large masses are involved. You can write completely. Otherwise, you can write down here. You can write down the book.
Unless
Gravitation is dash unless large masses are involved. The correct answer is actually gravitation is a weak force unless large masses are involved, and that is why we talk about heavenly bodies as far as Newton's law of gravitation is concerned. Heavenly bodies means what? All these huge planets, Earth, Moon, etc. We don't talk about the small objects available on Earth, okay? Because it's a weak force. Take down. Gravitation is dash. So you can write down the answer within the bracket. A weak force. That is the answer. No. A weak force. Second question. Force of gravitation. Write down. Force of gravitation. Force of gravitation due to the earth is called dash. Anyone? The force of gravitation due to the earth is called a dash. Very simple.
acceleration.
Gravity. So force of gravitation due to the earth is called a dash. So the correct answer is gravity. Okay. Next important. These are all very, very frequently asked questions. Next question. Force of gravity dash with altitude. Anyone? Force of gravity dash with altitude. Altitude wise decreases. Write down. So force of gravity dash with altitude decreases. Next question. On the surface of earth, the force of gravity dash from poles to equator. No. Decreases. Very good. I said the poles highest, equator less. Is it not? Yes. On the surface of the earth, the force of gravity dash means decreases. Okay? Decreases from poles to gravity dash from poles to equator. It means what? From poles to equator it decreases, and that is why at equator it is the least. Are you able to follow? Next question. The weight of the body is equal to the product of dash and dash. Anyone? Is easy. Mass and acceleration due to gravity. Okay. The weight of the body is equal to the product of dash and dash. You can put M and S, G. M is mass. G is acceleration due to gravity. Next question. You can go to that book. what does happen when the weight is shifted from one place to another place on earth?
Not constant.
It is not constant, it varies. So what does happen when the weight is shifted? Some weight of some material, some content, some luggage, say about a 2 tons coal. Okay, that is weighed exactly at the North Pole will be definitely different at equator. That's what we had discussed, is it not? So shifted to when the weight is shifted to another place on earth, another extreme place on earth, latitude wise. Actually this is called variation of G by latitude. Okay, so variation of G with the latitude, and also we had discussed variation of G with the altitude. This is latitude change. Okay, so it varies. Next, mass remains changing on the surface of earth. True or false? Mass remains
True.
changing. It is not changing, it's constant. That is false. Okay, so mass remains changing. Actually we should not call remains. Mass is changing, you can put. Mass is changing on different places. That is wrong. Mass remains constant. Okay. Next question. Given the weight is 49 kg, find out the mass of the object. How can you find?
Weight is equal to mass.
Very good. Weight is equal to
Mass
into acceleration due to gravity. Try.
So what should I take the value?
Sir, 480.2. 480.2.
9.8.
9.8. That is,
480.
what is the value? You write down the value of G first. What is the value?
9.8 meter per second square.
Meter per
Second square.
second
Square.
squared. Is it not? That is G. And here it is given as kg. Is it not? Then what about W? W is given as 49. You can mention 49 is equal to m into 9.8. Correct? So what is m?
9.8.
48 divided by 49 divided by 9.8.
5, sir. 5.
49 divided by 9.8.
It's 5.
That is 5. But that is gram or kg?
kg.
Kg. Okay. Variable follow. Good. What is the unit of weight? SI unit. Newton. Very good. In terms of kg?
kg.
Nm power 2.
Kg. In terms of kg.
Newton.
What is Newton?
kg. Kg m power minus 3.
Noda, W is equal to what? mg.
Yes, sir.
M is equal to kg. G is equal to ms power minus 2. So kg ms power minus 2. That's all. Okay, write down. So what is the unit of W, that is weight, is SI unit is Newton, but if you want to mention this in terms of kg, what you are supposed to do? W is equal to mg. You can use that formula. Is it not? W is equal to mg. Put mg. W, you can derive the formula, derive the unit. So m is equal to kg, small k, and g is ms power minus 2. So kg ms power minus 2. Do you understand this? What is the unit of gravitational constant? You can derive.
Meter per seconds.
Instead of memorizing, you can derive also. Okay? Vimrit, can you do? Can you derive that? Come. Do it in this book. Let him run. Come quick.
Which side, sir?
This side. So derive the unit of G from Newton's law of gravitation.
G is equal to
F is equal to G into M1 M2 divided by
D square.
D square. Right,
R
good.
square.
Right, proceed. Everyone can do. All of you can do this. Try.
Sir, what we want to derive, sir?
You have to derive the unit of G.
Capital G or small?
Capital G. See, first you take the G on the left hand side. How you can take that? No, there is a procedure, I will let you know. Just follow me. Listen, F is equal to, listen here, F is equal to, no, don't write anything on board. You have to write without referring to my notes. F is equal to, just follow, imbibe. F is equal to G into M1 M2 divided by R square or D square. Now I want this. So you have to eliminate all these things. What you are supposed to do, you have to, let us first eliminate the R square. So multiply on both sides by R square. Okay? Correct?
Yes, sir.
So R square cancel. So this is FR square. Right?
Yes, sir.
G M1 M2. And you have to eliminate M1 M2. So you can multiply by 1 by M1 M2 on both sides. So this is the way you can do. Okay? This is a very easy method.
Yes.
So M1 M2 can be cancelled. Now you have G is equal to FR square divided by M1 M2. You can interchange now. So this is safe. Got it?
Yes, sir.
M1 M2. Now we have derived G. Now let us evaluate G. We have to derive the unit. What is the unit for force? Newton. What is the unit for R? Meter. So meter squared.
Yes, sir.
Divided by, what is the unit for M1?
kg.
So kg squared. Correct? Therefore G is equal to Newton meter squared kg power minus 2. This is the SI unit. Now if you want to derive further in terms of kg. So what is Newton? Newton is nothing but the unit for force. What is force? MA. Is it not? So MA means here M is kg. A is acceleration due to gravity, ms power minus 2. So you can make use of this one. Substitute in terms of, in place of n. Therefore G is equal to kg ms power minus 2. Correct?
Yes, sir.
Then you have m squared.
M square kg square.
அடுத்தது kg power
minus 2.
minus 2. So it totally changes. kg power minus 2. So kg power minus 1. Correct?
Yes, yes.
Then meter squared. So it becomes a meter cube. Then second power minus 2. That's all. Okay? So you can give in terms of this one. Why I have derived this? Because it will be useful for you to get the dimensional formula also. I will let you know what is dimensional formula. Dimensional formula is nothing but, for example, if it is a length parameter, you can put L. If it is a mass, you can put M, capital M. These are all the dimensions. If it is a time, T, you can put it in T. Okay? So, this is mass, this is length, this is time. Usually mass is represented in terms of what?
Kg.
In terms of kg. So, the dimension formula is M. In the case of L, meter, the dimension formula is L. In the case of T, second, the dimension formula is T. Now, what is the equation we have got for G? So, G is equal to m cube s power minus 2 kg power minus 1. So, you can take the dimension formula as meter is length parameter L cube. Second is time. So, T power minus 2. kg is m power minus 1. So, the dimension, take down the dimensional formula of G is equal to m power minus 1 L cube T power minus 1. This is the way you have to write. Okay? Got it? Suppose if it is area, what is area? L squared, length into length. So, L squared is the dimension formula, and this is usually represented as there is no mass here, but L squared is there. There is no T here, so I can put m power 0, L squared, T power 0. Because m power 0 is equal to 1, anything power 0 is equal to 1. Okay, so you can mention as L squared or m power 0, L power 2, T power 0 also. Do you understand this?
Yes, sir.
What is the dimension formula for volume? Volume is nothing but LBH. So you can put LBH, means volume is L, this is also length, this is also length. So L cube, that's all. So how to represent this? M power 0, L power 3, T power 0. That's it. So likewise you can. Okay? Got this point? What is the dimensional formula of force? F is equal to MA. M is mass. Is it not? And A is what? Acceleration. Acceleration is nothing but meter per second squared. Meter is length. Second square T power minus 2. That's all. So the dimensional formula of force is ml T power minus 2. We will discuss in the +1 about the uses of this dimension formula. You can verify whether your formula is correct or not. Shall we verify? We can verify. For example, I said F is equal to, let us verify, F is equal to, what is that? G into M1 into M2 divided by D squared. Is it not? What is the F? F is, now let us, we had to prove by dimension formula. Let us take LHS. Okay? For F, we already know ml T power minus 2.
Minus 1, sir.
Minus 2, MA. Okay? Second is, velocity is LT power minus 1. This is LT power minus 2. And then RHS. Shall we take RHS?
Yes, sir.
Now what is the G? We already derived the dimension formula for this. You can make use of this. M power minus 1. That is M power
minus 1
L cube.
L cube T square.
T power minus 2.
T power minus 2.
Correct? Into, what is M1? M1 means mass.
Mass.
So M1, M2 means M square. Correct? And what about D squared? D squared, you can reciprocate it. L squared, L power minus 2. Okay? So M power minus 1, M squared is M
minus 2.
L cube L power minus 2 L, and you had T power minus 2. So this is RHS. Hence this formula is correct. In fact, I have some students who are always keen on checking the dimension formula, and based on the dimension formula they will be able to choose the correct answer for all MCQs as far as physics is concerned. So that is a trick. Okay? Right.
Sir, I have a doubt, sir. This formula is applicable for maths, sir.
Wherever dimension is there, it is applicable. After all, this is only max, volume, all these things. So wherever it is available, suppose if it is concerned with the counts, it is dimensionless. For example, even in Avogadro's number you cannot mention.
Yes,
It is mere count, 6.02 into 10 power 23, that's all.
Yes, sir.
1 dozen means what?
12.
12. 1 dozen apple means 12 apples. So there is no dimension involved. Okay. So as far as a dimension is concerned, there are some dimensional quantity, there are some dimensionless quantities. Okay? Right. So we'll continue in the next class. Can anyone summarize what we have discussed in the first one so that it will be interesting? Anyone? Come forward. Dayabaran, are you ready? Come. Take that first question because that is a little bit confusing. So what are the questions asked, and just give me the summary of those answers. You can take that book. Based on that you can explain what you have understood from that question. That first question is very important. Based on that, let us try to check whether we have understood the concept thoroughly or not.
So,
Yeah, tell me. Use the board.
so in
You can use the board. Here is it.
Sir, we saw that questions are like in the first subdivision, like the mass of one object is doubled.
Mass is doubled.
The mass of one object is
One object is doubled. It means there are two objects, M1, M2, where one object is doubled.
doubled. So in the second subdivision, the distance.
So what happens when mass is, you can write down, when one mass is doubled, what happened to the force? Force is,
The
force doubled or 4 times?
the force doubled by 4. Force.
We took two forces, FA, FB. Okay, what happened to FB? You have written
FB
already the summary.
FB is twice the FA.
Write down. When you write this question number 1, subdivision 1. When one mass is doubled. Write down like this. When one mass is doubled. When one mass is doubled, FB is equal to what? Twice the FA. Got it? That's all. It means the force is doubled. Second question.
The distance between the object is doubled and tripled.
Doubled and tripled. So in that case, a mass is you can ignore simply. Okay? So in that case, when D, let me say
D.
D2 is, you can put like this, D2 is twice the D1.
Twice the D1.
D1.
Then FA is equal.
Then FB becomes,
And D.
FB becomes, no, one by one you can go. FB becomes how much?
1/4 of
1/4 of FA. So what is the next question in the subdivision 2? When D2 is tripled.
Tripled of
D2 is tripled of D1. So FB is equal to 1/9 of Fa.
Then, third question.
The mass of both object is doubled.
Both the distance. Both objects are.
Is-
Both objects. So both objects means both M1, M2 doubled. Don't erase here. This is the summary, no? Why you erased it?
Sorry.
Mass of both objects doubled. So what happened to the force?
It's 4 times.
4 times of the original force, Fa. Okay? That's all. Good. And what is the another important concept you have understood today?
The
We talked about the latitude.
latitude.
The acceleration due to gravity, that is G is not constant. It varies from place to place. Since it varies from place to place, weight also varies, but mass remains constant. Okay. So what about the weight on pole?
It will be high. It will be
Uh,
high as compared to equator.
Equator. Good. And what is the next concept you understood today?
So the dimension from
Dimension formula. For what? For all this force,
for the force,
acceleration due to gravity, then gravitation constant. Okay? Is it thorough now?
Yes.
I think you don't have this Archimedes concept in this.
No.
Okay? Right. Right. Okay.